Hi, my name is Pearl, and today we're going to be solving this question from the engineering mechanics textbook. I'm going to be solving both of them in this particular video. So, determine the magnitude and rotation of theta of FB so that the resultant force is directed along the positive y-axis, that's vertically upwards, and has a magnitude of 150. Oh no, sorry, 1,500 newtons. So the first thing you should know is whenever we're dealing with x and y in force vectors into the space anyways, the summation of all the force in the x axis is equals to the resultant force x component, and the sum of component forces in the y axis is equals to the resultant force y component. We know that FR only has a y component, it has no x component. You can see it's only on the y axis. So for the x component, it's going to be 0 equals to. Now let's find the summation of the x components. First one is going to be for 700, going to be 700 cos 30 degrees plus FB at this point also has its own um x component. Notice that FB is in the negative x direction, so it's going to actually be negative FB cos the degree there is theta. You can see at this point here. To make FB subject formula, FB cos theta is going to be equal to 350. FB is going to be equal to 350 over cos theta. Now moving on to y, we know that the y is 150 newtons. You can see it was given in the question. Equals to 700 sine 30 degrees plus FB sine theta. I made a mistake here. Here's supposed to be sine, not cos. So the answer, the final answer is still correct. So make FB subject formula. Let's have the FB sine theta equals to 893.8. That means FB will now be replaced by the equation we had here, which is 350 over cos theta sine theta equals to 893.8. Sine theta over cos theta is actually tan theta. So going to be 350 equals to 893.8. And next you have tan, if make theta to be from you have tan inverse of 893.8 over 350 is going to be equals 63.61 degrees. And to find FB, we simply substitute back into the original formula. 350 over cos 63.61. We're simply going to have 787.44 newtons. Next, for 2.43, we're going to have 2.43 here. Determine the magnitude and orientation measure counterclockwise from the positive y-axis of the resultant force acting on the bracket if this time FB is given. FB is 600 Newton and theta is 20 degrees. So in essence, basically just saying that what time FB is given, this is 700 Newton and this will be 600 Newton, and theta, which is angle from here to here, will be 20 degrees, and FR is going to be somewhere around here, which is angle. Maybe let's say phi or something like that. Or let's call it theta actually. So if we were to solve this, again, I'm going to use the first rule I mentioned to you. The resultant x component is equals to the sum of all the components x components. Sum of all the component forces x components. And the same goes for y. Now, f rx is actually unknown. This time we actually do not know it. But the fx components will be 700 sine 30 degrees. You can see at this point, this is the x, this is the y, Visokatwa, plus 600. This will be, since this is 20, it will be sine 20 degrees equals to, when we calculate it, we're going to get 213.8 newtons. So that's FRX. FRY is going to be equals to 700 cos 30 degrees plus 600 cos 20 degrees. Sorry, I made a mistake. This supposed to be cos, supposed to be sine. This cos, this is sine. Sine 20 degrees, which is going to be equals to 811.4 Newton. The final answer here is still correct. Now, to find F will simply be the magnitude of F, that is, will simply be the square of its x component plus the square of its y component, which is simply 213.8 square plus 811.4 square. Squares everything. Punch this into a calculator, you're going to get 839 newtons. Now for theta is simply the tan inverse of Rx over FRY. This is why if you look at what here, tan, which is opposite over adjacent, this is F, this is FR, this line is FR, that means this is FRY, and this will be FRX. So to be opposite over adjacent, FRX for FRY will be tan inverse of 800, 213.8 over 811.4 equals to, the final answer will be 14.8 degrees. So this is our final answer. We've gotten the answer for both parts.